Great. Thank you so much, Marilyn. So yeah, with this presentation, I'm going to cover some of the topics that will be elaborated on in the design guidance document that we're putting together as part of the RELS project. But my main goal with this presentation is just to kind of set the stage for all of the great presentations you're going to hear to come. So Peter Bay's more detailed overview about estuarine beaches, as well as the case studies that we're going to hear. So I'm going to go over some of the key terminology and really just kind of set the scene for this discussion. Next slide. So I'll start with the need and the benefits of estuarine beaches. So we know that beaches are an integral part of the estuarine ecosystem. When we talk about the complete marsh system, from out in the bay up to the uplands, the beaches are a part of that. And we know historically the extent of beaches was much greater, and there were a lot of systems where beaches integrated with marshes as part of a combined system. There are still many of those in the bay today. But as we know from the Baylands Goals project, there's a target to increase the extent of beaches for habitat purposes. Another big need is due to sea level rise and increasing coastal erosion. And beaches become a very valuable opportunity here because they can be an alternative to armoring to reduce shoreline erosion. So they can be a more dynamic system that provides more habitat benefits than a traditional armored shoreline. When it comes to benefits, there are a number of wildlife and plants that benefit from estuarine beaches in the bay. For example, they are very valuable for shorebird roosting habitat, among many other things. When it comes to shoreline resilience, I already mentioned they can help buffer from waves, reduce shoreline erosion, and that can be whether they're in front of a developed shoreline or in front of a marsh, as a marsh fringing barrier beach that can reduce marsh scarp erosion. And then public access and recreation. We know there's opportunities with this as well. Next slide. Some key considerations that we'll cover in the design guidance are shown here. So Peter will go into much more detail about this, but estuarine beaches are a very distinct form from the coastal beaches that many of you may be more familiar with. Because estuarine beaches are in a more low energy environment where there's smaller waves, the form tends to be quite different than those open coast beaches that you might visit, for example, out at Stinson Beach or Ocean Beach here in our region. There also, in the design guidance, we need to consider both the habitats that we're trying to create as well as the processes to sustain them. And that's really true for any type of restoration or adaptation project that we do, but in particular for beaches, which are very dynamic systems. And then um, we also need to consider the local settings. So there are a lot of, varied settings around the bay in terms of waves, tides, bathymetry, topography that really drive the differences that we see in what beaches look like around the region, and that really drives the opportunities and constraints for the design of these beaches. Next slide. So I'm now going to go over some of the terms that you'll hear, so hopefully you'll be more familiar with them as we carry forward with the presentation. So I'll start with a low tide terrace, which is something that is a very important consideration in estuarine beaches, in particular compared to those open coast beaches. So the low tide terrace are the intertidal flats that are bayward of a low energy estuarine beach. The next term
Hey,
I'll,
Ellen, I'm
yeah.
so sorry. There's a little bit of chat going on that some folks aren't seeing slides or seeing slides
Oh,
advance.
okay.
Um, can anyone speak up if you're not seeing slides besides Julian? And can anyone speak up if you're not seeing slides advance? Okay, I think most of the group can see, so I apologize, Ellen. Let's continue, and apologies to the couple folks that are having issues. Hopefully we can work that out.
Okay, yeah, no worries. So just defining some of these terms here. So the beach face, that's that sloping section where the waves swash and backwash up and down the beach at higher tides. The berm crest, that's the break and slope between the beach face and the beach berm, which is that flat section that's formed by sediment deposition on the receding tide. The washover area, that's where we get flow over the crest of the beach during particularly high water level events, resulting in sediment deposition in the backshore. For in this case, this is a marsh fringing beach, so This is a wash over into the salt marsh behind. And then you also may hear the terms foreshore and backshore. Foreshore is that intertidal zone that's exposed to wave action on a daily basis, where backshore may only be exposed to wave action from the bay during those extreme events. So on to the next one. Another few terms to be familiar with that we'll be talking about a lot today when we talk about the plan shape or the plan form of a beach. We're talking about that view looking down from above. So thinking about the topography that's shaping the shoreline. Are there natural headlands on either side of the beach that are creating a pocket for that beach to live in? Or perhaps artificial structures like groins that are designed to shape that plan form and that plan shape and trap sand on the beach. And then we'll also be talking about beach profiles. So that's the cross section of the beach, like you're seeing in the lower image here at Radio Beach. Next slide. In the design guidance, we'll go into this in more detail than we can today, but beach conditions really vary by province in the bay. And so you're seeing a map of some of the beach provinces in San Francisco Bay on the right side of the screen. So you can see beaches are most dominant in the Central Bay, the Contra Costa shoreline, as well as down in San Mateo. And so these are the historical areas where beaches existed and where they're most likely to persist today based on the wave conditions out there. But they vary across the bay. So there's different wave climates, different shapes and settings of low tide terrace and nearshore conditions, various sediment types and sediment supplies that Peter will get more into detail on that we need to consider when thinking about the design of bay beaches. And we'll be sure to share this map as well as the associated information with the materials coming after the meeting. Next slide. So when it comes to the design approach for estuarine beaches, the first thing, like with any project like this, is to set the goals. So thinking about what are the ecological goals, the habitat goals, as well as the physical goals in terms of potentially, reducing shoreline erosion and things like that. We also need to think about the site setting. So what are the wave conditions in this particular area? Is a great one. Also thinking about that, the topography, the water depth, the bathymetry, et cetera. Very important to think about in the site setting conversation because these beaches tend to be a little bit more constrained in terms of what the opportunities are than maybe some other types of projects that we all might work on, like marshes. Reference sites are very important. So we have quite a few intact beaches in the bay, as well as a number of modified beaches, as well as some existing pilot projects to work from now. And we'll hear about some of those reference sites and reference projects today. Sediment and supply. So where is the sediment supply coming from? How is it going to stay on the beach? How frequently might nourishment be needed to maintain the beach are some important questions. Thinking about the beach profile, what is the volume of sediment placement that is needed to allow the dynamic system to function properly, to allow movement to occur? Thinking about the plan shape. So what's the existing setting of this shoreline? Is it in a pocket that can be more self-maintaining, or do we need to think about putting out artificial structures to try to contain some of the sediment that's placed and make sure that these projects are more durable? Thinking about feasibility and construction, super important to consider, what does the access look like? How is this material going to be placed? There are a lot of projects that may be great projects, but they're very difficult to build just based on the setting where we're located. So we need to be creative from that perspective. And then finally, thinking about monitoring and managing. These beaches are extremely dynamic. They tend to vary dramatically season to season, as well as year to year based on the storm conditions. So how do we monitor and manage these, set appropriate triggers and thresholds for management actions to occur? So I'll conclude there. You're going to hear a lot more about all these topics from Peter. So Peter, I'll go ahead and pass it over to you. Thank you so much.